Hey guys, what's going on? You excited to learn? This is going to be a very intuitive video, so strap your boots and let's get into it. But before we start the video, I want to ask you to subscribe to the channel. I'm trying to hit that 100 subscriber milestone. It would be much appreciated if you subscribed because I do a lot of content like this. And before I show you how to do this, let me show you a demonstration of what it looks like. We have an enemy patrolling on a platform, and every time it hits an edge or a wall, it just simply turns. And you can adjust his move speed down here. Let's get right into it. This is going to be a super cheap on performance and effective script on the enemy here. So all I have here right now is a blob jumping animation. If you want a tutorial on this, let me know. It is super duper simple. Making animations is just too easy. Making this literally took me like 2 minutes. And on my enemy right now, I have a sprite renderer component and I have an animator, which does not matter. You don't need it. The first thing that we're going to need is a rigid body 2D. I'm just going to put the body type to kinematic, which means it is not affected by gravity. Now I'm going to add a box collider 2D right here, and I'm going to press edit collider here. And let me just show you how I'm going to set up this collider here. I'm going to shrink it down a little bit, and I'm going to drag the offset on the Y a little bit down. This is going to be our ground detection. And I'm also going to push it out a little bit. There you go. This is going to detect an edge or a wall. And the next super important thing we need to do for the box collider is set is trigger to true, because this isn't going to collide with anything. It's going to be a trigger. Now I'm just going to make a new script for this, and I'm going to call it enemy behavior. You could call it whatever you want. This is what I'm going to call it. And let's go ahead and open that up by double tapping it. Alright, so I'm just going to clean up these comments. And we are going to be using start and update. But I'm just going to kick it off with some variables. And we actually only need one. So that's cool. Serialized field. And it's going to be of type float. Float because it has decimal places. And I'm going to call this move speed. This is going to dictate the speed of the enemy. I'm going to set that equal to 1f. You have to put f at the end whenever it's a float. And now that we have our variable, I'm going to have to cache some references. So we're going to have to cache our rigid body 2D. I'm going to call it my rigid body. And we're going to need to cache our box collider. So cool. Now we have two cached references, but now we need to initialize them. And we initialize cached references in the start function. So I'll go my rigid body is equal to get component. And what get component does is it gets these components on our object. Very, very simple. If you're going to be coding, you're going to use this line about 1,000 times. And we're going to be getting our rigid body. And it's 2D, of course. And close that off with some parentheses. And now let's initialize our box collider. So my box collider. And now the script knows exactly what we're talking about when we say rigid body and box collider. So first off, I'm just going to code the edge and wall detection. So I'll do that by making a function called private void. And you can't name this whatever you want to. It's going to be on trigger exit 2D. Now make sure you let it autocomplete, or else it's really easy to mess up this function. And what on trigger exit does is when a collider exits another collider, then it'll do whatever's in here. So what we want to do is we want to just simply turn. That's it. I told you guys this was a very simple script. And to do this, it is very simple. We'll go transform.local scale. And what local scale is it gets this transform component and it gets the local scale right here. And we're going to say that's equal to a new vector2. And guys, this is where the cool part comes in. We're not just going to say -1. No. We're going to say minus, and we're going to put in a mathf dot sign. Whoa, what is a mathf dot sign? Well guys, you should get pretty comfortable with mathf because mathf is very effective and efficient. So what sine does is it returns a value that is either 1 or -1. And this is perfect because +1 is looking right and -1 is looking left. And when we say -1, it also flips our ground check collider right here. This is literally perfect. And as a parameter in here, we'll just say my rigid body dot velocity dot x, because we're looking for the x, and let me spell this right. And then we'll jump out of these parentheses right here and put a comma. Now this is the first value of the vector 2. Now let's put in the second value. Transform dot local scale dot y. Now instead of all this, you could just put 1f, yeah, cool. But if your character is a different size from 1, then you're going to be changing the size of your character. So by simply saying transform.localScale_y, we're just saying keep the y scale exactly the same. And instead of saying all of this, we could have just simply said -1. But if we did that, we would have to copy this line of code again and then say +1. But put this in a different function. So guys, this is what I meant by very efficient code. Just one very simple line of code. It is perfect. Now all this does is flip our sprite. Now we need to move our sprite in a certain direction. So to do this, I'll make an if statement in update saying if is facing right. And this is going to be a function. I'll make it really quick. And it's going to be private. And it's not going to be void. It's going to be a bool. So this function is going to return a boolean, and as it says up there, it's going to be called is facing right. And when a function isn't void, you need to return something, so we're simply going to return transform.localScale.x, because that's what we're looking for. And since this is a bool, it's either going to be true or false if our x value is more than, and look at this guys, another very cool syntax, mathf.epsilon. Now instead of saying epsilon, you could simply say greater than a very, very small value like this, but that's janky. No. Just simply remember mathf.epsilon because epsilon is simply just checking for a very small value. So we're saying if it's greater than a very small value. This is very effective. And we simply close it off. That's all we need for this. So we'll go if facing right. And you can come in here and say equal to true. But it means the exact same thing. So you don't need to put that in there. And if we want to ask if it's false, we'll just have to put an exclamation mark there. But we're checking if it's true. So if we are facing right, we want to move right. Or else, if we're going to be moving some other direction, which we will, we just simply want to move left. So to move right, we get our cached rigid body. We say rigid body dot velocity again is equal to new vector 2. And this is where we're going to shove in our move speed variable in here. Now you could just say 1f, but that's just baking it or hard coding into your code. So we stick in our move speed variable. That way we could change it inside of the inspector. Oh, this is supposed to be 0, my bad. And now all we have to do is copy and paste right here and just say minus our move speed, which will make us move left. And guys, I'm not kidding you. That's literally it. Normally you would see tutorials showing you a script that is like twice as long, but since we're using this mathf stuff, it is just super effective. And usually on YouTube you would see something like a bool is facing right. But we don't need that because we have a function and the function automatically sets itself true or false depending on where we are moving. So that is very efficient. And you know what? I don't even think I needed to cache our box collider, but let's just see if it works. So if we hit play, he's going to move up and turn. And he's also going to move to the wall and turn. Cool. Now you could also go inside the enemy and change his move speed to something like 3 if you want him to go super fast. I'm going to jump back into my script, and like I said, I realized we don't even need a box collider, so now it's even more simple. Thank you guys for watching. I hope you enjoyed the video. If it helped you out in any way, please subscribe to my channel and help me to hit that 100 subscriber milestone. And if you want a tutorial on player movement and jumping, and ladder climbing, let me know in the comment section below. And with that being said, I'll see you in the next video.